Would it be possible to for speakers to ask for the audio so that we can double check the audio is working? Ketan, François, you have the audio?
Hi, hello, Bruno. Good afternoon. Can you hear me?
Yes, perfectly. Thank you.
Okay.
Hello, François. François, we are not hearing you. I have the request, but you keep disconnecting. Shraddha.
Hello.
Yes, we hear you. Thank you.
Thank you.
Hi, François. No, still. Yes. Do you hear me, François?
Yeah. Can you hear me?
Yes, perfectly.
Okay, great. Thank you, Bruno.
Okay. Other than that, I think we're going to start because we have a full schedule. So welcome to the Spring Working Group. Good morning, good afternoon, and good evening for everyone. So we are the first using Meet Echo. So eventually we'll have some issues, but hopefully we'll be able to run an effective meeting. Please have a look at the Notewell. This is the usual Notewell, but probably we have new participants, so it's important to read it because you have to comply to the Notewells. Next slide, please. In terms of minutes, we're going to use the not remember the name, but the collaborative note-taking tool, which is available either in Meet Echo or in a different tab or browser if you want. Shopping is going to take notes, but you're welcome to contribute, to correct your statements or your name. In terms of Jabber, everyone can use a Jabber, but it's difficult for the chairs to see both queues on Jabber. So if someone want to relay the Jabber questions, it would be welcome. Next slide, please. Thank you. So in terms of working group personnel, Rob Shakir has stepped down. Thank you very much, Rob. It was really, I enjoyed working with you. And now we have two new chairs, Jim Kishar and Joel Alpen. Welcome, Jim and Joel. Do you want to to say something? No, but at least I'm very happy to have you on board. So now we have three co-chairs. In terms of document updates, so let's start with working class code. We had a working class code on SRv6 network programming. So we have people on the queue. Linda, do you want to say something, or it's just a test? It's a test. So we had a working class code for SRv6 network programming. The working group class code has passed after a long time, and the document has been sent to ISG. Then the appeal has been sent to ISG, so you have the URL to check the detail of the appeal. And then the ISG has given its response to the appeal. Again, you can have a look at the response. But in summary, the document keeps progressing, so it's not returning to the working group, and it's not having a second working group class code. The ISG is asking for some actions to clarify the content of the document in order to be in line with the discussion in the working group. And we have a new shepherd, which is with Joel. Thank you, Joel. So as of today, the draft has been updated to comply with the action asked by the ISG, and Joel has updated the shepherd write-up. And so the current state is AD evaluation. So it's on Martin. Next one, we have another working class code on SR Young. So working class code has passed, and we are waiting for the shepherd write-up. Next slide, please. So in terms of working group adoptions, we have called for adoptions for drafts. The first one is a draft for Spring SR replication segment, which has been adopted as a working group document. So pending being refreshed. So it is describing a local replication on a node, and there is a corresponding draft which is to be worked in the PIM working group, which is going to work on creating a replication tree or states in the network. But it's for PIM working group, so the name of the draft is just for reference. Next one, there is a call for adoption for draft Dong Spring SR for enhanced VPN, which is underway and ending Wednesday this week. And also we have a call for adoption for draft Rasa Spring SR Policy Young, again ending today, and a call for adoption for draft Rasa Spring SRv6 Young. So call for adoption underway, ending today. So you're welcome to review the drafts and comments. We would appreciate comments in addition to +1 or yes, because it's more it's a more detailed feedback and it's more useful. Next slide, please. Then probably a big item for the working group is to work on SR over IPv6, but with a compressed header. So there has been multiple proposals in terms of draft, which are being proposed. There are also some draft proposing requirements and the comparison of solutions. So we have created a design team in July, 7th of July, so about 3 weeks ago. So you can have the details on the mailing list. In short, the design team is tasked to produce 2 drafts on 2 topics. The first is to detail the requirements. So what really do we want for the solution to be? And then the draft to compare the proposed approaches. So all the possible approaches, it's up to the design team to select the proposal and to do the comparison. But in terms of guidelines, the design team is really asked to explain and motivate the requirements, not just give a list of requirements. Because at this point, we should not assume that everyone has the same position or understanding of the requirements, and so people are coming from different position and scope. Next slide, please. So obviously, we would like the solution, the output of the design team to be available shortly. But more importantly, is to be able to have a good output, so good drafts, in order for the output to be useful for the working group. So the priority is the quality of the output of the design team. We need clear and useful agreements. However, we would like to have at least a first feedback by September 15 for the working group to see a first output of the design team, and then we'll see for the next milestones. As a reminder for everyone, working group on design team, the output of the design team is to be used as an input to the working group. So it's just an individual draft, just like any other individual draft. There is nothing special from a working group standpoint. And if we have a call for adoption, it will be up to the working group to decide which draft to adopt or not to adopt. So eventually the drafts from the design team would not be adopted. And finally, the main goal is to progress on better understanding the requirements and the solutions. At this point, we do not assume that the documents will progress to RSA.
One small clarification, Bruno. Your verbiage on the previous slide led some people to think that we were telling the design team to select the solutions, and we're not asking them to select the solutions. But that's just a minor clarification.
Yes, thank you, Joel. No, we are asking the design team to propose 2 documents, one on requirements and one on comparing solutions. We are not asking the design team to pick a solution or a set of solutions. In terms of people, the design team is co-chaired by 2 persons. First, Cheng Wenqiang. Sorry if I'm not saying your name very well. From China Mobile. And then Sander Stefan of SGM Stefan Consultancy. And other members of the team are Ron Bonica from Juniper, Darren Dukes from Cisco, Cheng Li from Huawei, Peng Xiaofu from ZTE, Wim Hendricks from Nokia, and Chongfeng Zi from China Telecom. So we've tried to select a set of vendors and network operators interested in the solution within the set of candidates that we received. And we have no more than 1 person per company. Next slide, please. So finally, this is the agenda for today. We have a full agenda, and we are already at the end of the slots for the chair. So speakers, please limit yourself to the time slot that you have, which include both presentation and discussion. Because we don't have much time that what you have, so we would eventually need to stop the discussion at the end of your time slot. Any comment on Tisna, you're on the queue. Do you want to say something? No, eventually no. Tisna? Cheng? You are on the queue and you have the mic. Do you want to say something?
Hello,
Yes.
can you hear me?
Yes, we do.
Yeah, cool. So I saw on the previous slides
Yes.
that the chairs
Can
are
you just present?
crossing
Can you just present yourself? I guess you're Cheng, but
yeah. Charlie from Huawei. Like as the discussion, the design team, we thought that the second draft is an analysis document instead of a comparison document. Yep.
yes, good point. Thank you. And by the way, there is a slot in this meeting for the first feedback from the design team. So this is the third slot.
Cool. Yep. Perfect. Thank you.
Thank you, Chen. So next on the agenda is Ketan. Ketan, you should have the mic.
Okay. Thank you. Good morning, good afternoon, and good evening. We wanted to present an update to the SR policy architecture draft. Could we move to the next slide, please? So the SR architecture, just to give an overview, the SR policy architecture draft covers the framework and information model of the SR policy, which is really one of the key fundamental blocks of the SR architecture for creating the SID list, or the source route information that is actually set up in the packets. It has all these things, including the steering mechanisms. I didn't mean to read through all of it, just to give an overview. Could we move to the next slide? So the draft was presented, along at Ietf108. So very early on, it is one of the key milestone of the working group. It was adopted at Ietf101, and we last presented this document at Ietf102 almost 2 years ago. So since then, there have been many discussions on the list. There have been reviews, comments, and some of them happened offline as well. So over this period of time, the document has undergone several revisions, and we have kept posting the updates on the list. We also would like to share that draft has a lot of implementations across multiple vendors, as also deployments quite widespread in multiple operators. Move to the next slide. So we wanted to walk over the like a high-level summary of updates that have happened since the last presentation, and most of these are clarifications and editorial in nature, but few important ones as well. On the candidate path selection, there was some doubts, or there was some confusion on the protocol origin values, and we had to put in a clarification. These are actually more like priority values to determine which one gets precedence over the other. For example, locally configure gets preference over what is signaled via PSEP or BGP. Then there was some BGP protocol specific details that were in this draft about originator information, and these have been moved with the appropriate updates to the BGP SRT draft. Again, further clarification on the tie-breaking rules on preference. We had two names in the draft. One is the SR policy name and the SR policy candidate names, and there was in some cases a confusion between these and how are they signaled in various protocols. So those clarifications were updated in the document. Then we, a couple of updates ago, we introduced a mechanism. There was a requirement for, ability to simply kind of pop the BC label and do a lookup and forwarding based on the underlying IP or label. And this was more like a fallback kind of a mechanism. And so we added, explanation of how that could be done using the existing architecture or semantics. Next slide, please. And then there were update of terminologies. The SRv6 network programming is past working group last call. So we have updated some of the terminologies related to SRv6, basically behavior, function, and some segment types. They were updated in the latest document. And there is also the IANA registry set up for the SR policy segment types. And in the last version, which was updated a couple of weeks ago, we have also updated security considerations. So this is a high level update, not going into each and every changes. Move to the next slide, please. And this would be the last. So as I mentioned at the start, we wanted to give an update on the status and where and how we want to go ahead and accomplish this critical milestone for the working group. So as a next step, there are a couple of things that have come to author's mind. One was there is a feedback for including some examples for candidate path selection. The draft includes the tiebreaker algorithm and how they are picked up. Some of these examples were there in a different draft, and there is a proposal to move this into the appendix section, so they are not normative, simply examples of this draft. And then authors are also aware, and there is ongoing discussion about a use case of more, let's call it composite constraints, basically not just a single one constraint, but what if SR policy had multiple constraints? How do we solve or address that? So that's still in work, and these are the two things that are pending or we are going to work on. I would like to invite further review and feedback from the working group, and if there is anything else that needs to be taken care of before we call for working group last. We do the working group last call for this document. Yes, I think Himanshu is in the queue. Himanshu.
Himanshu, do you want to say something? You have the mic. Himanshu Shah?
Rather than using the Q button, so I assume it was a test, and we'll remove that.
Okay.
Okay. Yeah, please welcome reviews and feedback on the document. As I mentioned, we want to try and take care of these updates and post them on the list, and then move towards working group last call for this document. That's all.
Thank you, Ketan. Thank you for the extra 5 minutes. And yes, it's important to review that document. It's a big and important document for Spring. It is using Spring for non-best effort usages.
So, hello?
Yes, we hear you.
Yeah, yes. So this is Wei Changcheng, and could I start this slide presentation?
Which one?
Yeah, could you hear me?
Yes, we do hear you, yes.
Yeah, so thank you, Chair. I think we would like to give you a brief introduction of the design team for SR over IPv6 compression. So next page. I think just now, chairs have given a very detailed description of the scope of the design team. And according to the email from Charles, the design team will produce draft recommendations. That is just an individual draft to a working group on 2 related topics. The first one is what are the requirements, and the second one is analysis document, which maybe cover the comparison and some other metrics. And the design team have been introduced by Charles, the co-chair from Wuchang, that is me and Sander. And we have some other members, Ron Bonica from Juniper, Darren Dukes from Cisco, Chen Li from Huawei, Shao Fupeng from ZTE, Wim from Nokia, and Chun Feng from China Telecom. So next page. So we would like to give you a brief introduction how we will work. So we have applied a mail list. You can access it. The mail list is private, but the archive can be read by anyone. And the documents for the drafts, we will upload it to the data tracker of IETF. For us document, we have already applied a space in GitHub. The list, the link is here. We will ask for all the meeting minutes and the documents and make them accessible by anyone. And we will have meetings. The e-meeting, we will book a bi-weekly meeting, and we will start after this week's meeting. We will use the Zoom as the tools. Maybe some others from the design team can also join us. And we hope in the future we can have a face-to-face meeting during IETF meeting. Next page. So here is the basic plan for the design team. We would like to have two stages. The first stage is from this meeting to next meeting, and the main task we hope to discuss the requirements and metric for SR over IPv6 compression, and the design team will focus on the document to help working group to understand the problem statement, requirements, metric, and the scope of SR over IPv6 compression. We will have an output draft that will cover the both data plan and control plan. And as just Charles mentioned, we may need to prepare a rough draft before September 15th. I think that is a little bit challenge for us. And the second stage will be between IETF 109 to IETF 110. The main task we will discuss the data plan and the control plan solutions, and have some comparisons based on the requirements document. And the design team will output analysis document, which will cover different solutions for SR over IPv6 compression. And here we would like to pay your attention. We are putting the drafts which describe the different solutions for IPv6 compression. that is an existing draft, and which we will use as the input for the analysis draft. And the output, we will output analysis document that will include evaluation information based on the requirements document. So that is the basic work plan for the design team. Next page. Next page. Yeah. So we have began to work on the requirement draft. So now the main content for each requirement candidate, we will have 3 different items. The first one is a description to provide some clarification for the basic information. And the second one is a rationale to explain why the requirement exists. And the third is a metric that can be evaluated in the analysis to determine how well the solution satisfies the requirement. And now here there is an existing draft there, and we will use some input, some content of that as input. We also call for some existing requirement related drafts that will be used as the initial input for this requirements draft. And each requirement listed in the draft will be treated as the candidates to be included in the design team document. That means no matter the requirement have been described in any draft, we will evaluate in the design team again, and we will generate a new draft in the design team. In the next page. So yeah, that's the basic information of the design team. Any comments or questions?
Yes, I have one comment, and then Andrew is on the queue. Regarding the time frame, I'm not sure whether this is the time frame of the latest version of the draft or the first one, but we'd like a more frequent or a first feedback sooner. I know it's difficult, but it would be good to have a first feedback to be presented to the working group by September 15. And then maybe every 2 months or something like that. But so the current time frame in 9 months seems a bit too long. But we'll work with you. Andrew.
Yeah, thank you. Yeah, and we will try to do that because we just begin the work, and there are a lot of uncertainty. So
I understand the topic is very difficult. Yes.
Yeah. So we will
Andrew,
try to finish. Yeah. Thank you.
Andrew?
Can you guys hear me okay?
Yes.
Yes.
Yeah, it's Andrew here. I also just wanted to comment on that time frame. 9 months seems like a long time, particularly considering that there are operators like ourselves that actually have a fairly dire need for this stuff. And I realize that things take a long time in the IETF, but 9 months, considering the fairly long time frames that have been involved in the discussion of these things, already before the design team just seems yeah, it's problematic, and I'd really appeal to the design team to see if we can't find a way to fairly dramatically shorten that time frame so that we can get some movement.
Okay, so thank you. And this current the time frame have been agreed by the design team. I think it's really challenged for us to get agreement on the requirement and the analysis. But as you mentioned, we will try to do that. Currently, the time frame is just a rough plan. I think if we can work more efficiency, and I think that will speed up the progress. Maybe we can shorter the duration to get agreement. We will try to do that. Thank you.
Thank you. At minimum, it would be good to have more frequent update to the working group for the working group to follow the progress or non-progress, but at least to follow the work.
Yeah, thank you.
Thank you. Next on the agenda was François for service programming. Yes. François, you have the mic.
Do you hear me well?
Yes. Thank you.
Okay, great. So good morning, good afternoon, good evening, everyone. I just wanted to give you an update on this service programming draft. As you know, this draft was adopted by the Spring Working Group last year, and there were a couple of updates since then, so I just want to go through them. Next slide, please. So in summary, since the working group adoption, we have updated the pseudocode for both SRv6 and SRMPLS segment behavior. The high-level behavior is still the same for all the different proxy variants. The new pseudocode is only more formal than the previous one, and in the case of SRv6, aligned with the pseudocode improvements that were made in RFC 8754 and later on in draft Ietf Spring Services Network Programming. We've also added a missing pseudocode, so that was for the caching flavor. The behavior was described at high level, but now in that new version, we have a proper pseudocode as well. And then some other fixes and changes in the INS section, and also coming from feedback that we received over the past year on the mailing list. Thank you for all who commented on the draft. Next slide, please. So the SRv6 behavior update, as I said, is only meant to make the pseudocode more formal and to get alignment with the pseudocode template that is provided in RFC 8754. The high-level behavior is unchanged. The proxies that we define are still doing the same thing. And if you look at the current version of the draft, you will see that all of the proxy pseudocodes are separated in three parts. We have the heap processing, the upper layer header processing. So these two blocks are inherited from RFC 8754 and the network programming draft. And we also have a third block that is for the return traffic, and that is specific to the proxy behavior. But same formalism for all three of them. Next slide, please. For the SRMPLS pseudocode, we followed more or less the same model. The goal was also to make it more formal, but without changing the high-level behavior. So this is an example for the static proxy with IPv4 traffic. You have, on one hand, the heap processing and on the other hand, the return traffic processing. Here, there is no upper layer header processing because this does not apply for SRMPLS. Next slide, please. Regarding the new, the new pseudocode that I mentioned before, this is for the masquerading proxy, and in particular the caching flavor of the masquerading proxy. So it is meant to allow the network function, the service function, to generate its own packet and to have those sent in the right service chain. The behavior at high level is the same as the dynamic proxy. It was briefly explained in the previous version of the draft, but now we have a proper pseudocode for that one as well. Next slide. And the last significant update was regarding the IANA table. So before we had one behavior code point in that table for each proxy behavior, as well as for the SR-aware service function. Now we have new code points for all the flavors of the masquerading proxy, because this is currently the only one that has flavors. And again, this is to better align the draft with the network programming draft, which also defines different code points for each flavor of the behaviors. Next slide, please. So as you could see, the changes that were made were mainly editorial or get more formalism on the existing content. Aside from that, the draft was quite stable. And so at this stage, we really would like to solicit input and feedback from the working group. So we already got some emails yesterday during the weekend from Joel. Thank you, Joel. And if anyone else has any comment or any input to provide on this draft, please speak up. Thank you.
Thank you, François. Don't hesitate to ask feedback on the mailing list if you want. You don't have to wait for a meeting.
Sure,
if we don't have comment, let's move to Thomas Graf. Thomas, are you with us? Yes.
Hello, can you hear me?
Yes, we do.
Perfect, thank you. Thomas Graf from Swisscom. I'm here presenting a draft where we are adding segment routing dimensions into IPFix. Next slide, please. So as you're well aware, MPLS segment routing is using the MPLS data plane. So on the right-hand side, you see packet capture coming on a MPLS segment routed forwarded packet exposed by IPFix. And as you can see, as not to no much surprise, the MPLS labels are still the same. Top label address is the same. Top label prefix length is the same. But what should have been changed is actually the top label type. In this vendor implementation, it's still referencing LDP, even though it was forwarded with MPLS segment routing. Next slide, please. Yeah. So looking at IANA, where we have the IPFix registration into the IPFix MPLS label type registry, we can clearly see that segment routing is not present yet. So we are missing ISIS, OSPF v2, and OSPF v3 segment routing extensions in here. Next slide. But that's not all of it. As you know, segment routing has SIDs or different SIDs type. This SIDs type basically describing an instruction, a segment, a service on the network. And by having that information, that dimension also present in IPFix, that would allow us to get deeper insight why a packet was forwarded in a particular way. So for instance, if you take the TI-LFA application, there it's about adjacency sits. So next slide. So imagine for one moment that we would have the SRSID type dimension as well. If you are collecting now from a particular traffic which was redirected through the TI-LFA, we collect the IPFix information in a database that would make it really easy accessible. We can do a simple query by saying, show me all the adjacency sits or the traffic which was redirected by adjacency sit, group them by label stack, and show for each label stack through which nodes and interface it was forwarded. So in plain English, what's missing currently at IPFix is the MPLS top label type and the SRSID type. Next slide. So I was already collecting feedback from the Spring and the Ops AWG working group. Thank you very much. I submitted this to IANA and I received the first review from the IPFix entity doctor. I'm looking from further feedback from Spring and Ops AWG and planning to adopt at Ops AWG tomorrow at Ietf108. If you have any feedback, looking forward. Thanks a lot.
Thank you, Thomas. So it's a document for OpsWAG, so it's not for Spring, but it's related to segment routing. So
exactly. So
some feedback.
Exactly. So I decided to show it on both working groups.
Yes, thank you. And maybe you could also send a short email to LSR working group, because your allocation, IANA allocation, are related to IGPs. On one question, maybe whether we need one for OSPF v2 and one for OSPF v3. So maybe LSR would be also interested. It's probably too late to ask.
Sure, makes sense. Thank you very much.
Thank you, Thomas. Okay, so next I believe Shraddha. No, yes. Shraddha, you have the mic.
Hello, everyone. Can you hear me okay?
Yes, very well, thank you.
Thank you. So, so the topic for discussion today is seamless SR. I am Shraddha Hegde from Juniper Networks, presenting on behalf of my co-authors. Next slide, please. So we will discuss the introduction, use cases, and the proposed solution and some examples. Next slide, please. So what is seamless SR? So seamless SR architecture is based on seamless MPLS architecture, basically multiple IGP domains, and then seamless MPLS used BGP LU to interconnect these domains. So seamless SR accommodates heterogeneous networks. So one domain could be running SR and another domain could be running RSVP or LDP, and then a BGP is used to interconnect these domains and provide end-to-end services. So the main point in seamless MPLS architecture is that the services are configured only on the service endpoints and not on the border nodes in a multi-domain network. So seamless SR also extends seamless MPLS. It supports end-to-end slicing. It also supports native MPLS for IPv6 networks. And it provides a way to interwork with other IPv6 technologies such as MPLS over UDP, MPLS over GRE, SRM6, and SRv6. Next slide, please. So let's talk briefly about the use cases. So 5G transport network, 5G is expected to bring new requirements on the transport networks because of massive bandwidth, end-to-end low latency requirements. And then because the network functions are virtualized and distributed, timing and latency becomes very important in the transport network. So 5G network, because of the huge scale of the network, 5G network is also expected to have fewer protocols and then stateless and programmable approach on the transport network. So high availability and high scalability are other important points, and application aware routing as well. Next slide, please. So large scale service provider networks, when they move towards 5G, so the number of nodes is expected to increase to a very large number. In some network cases, in a very large networks, the order could be, the number of nodes in the network could be in the order of hundreds of thousands. So such a huge network generally is organized into multiple domains with single ownership. So in such a network, the end-to-end slicing requirements and service level objectives need to be met in a multi-domain network. So another requirement in service provider network is also be able to do low latency routing. So next slide, please. So second use case is large scale WAN networks. So when the WAN networks consist of several thousand nodes, then it is useful to have smaller IGP domains. So the smaller IGP domains reduce the blast radius of the network events. So the domains are, the fault domains become smaller. So having a smaller domain also helps in reducing overall state on the device. It is useful to have organize these large-scale WAN networks into multiple domains. So in such networks, end-to-end traffic engineering constraints, which are imposed by requirements such as data sovereignty, need to be met. Even if we use, even if some deployments use controller-based solutions which can look into each of these domains and get the database and build an end-to-end path for end-to-end TE constraint, the network still needs to have for use cases, I mean, for scenarios when the controller connectivity goes down, the network still needs to have the end-to-end TE paths built in so that it can use in case there is a failure. Next slide, please. Next slide, please. So the third use case is a data center interconnect. So this network diagram shows data centers connected via a core. So many applications that run in the data center may require end-to-end path diversity. For example, here we can see that there is a red path and a blue path end-to-end. And there could also be a requirement to have low latency paths. The requirement is also to avoid service routes on the ABRs and then provide end-to-end connectivity with the BGP that satisfies these path diversity and low latency requirements. Next slide, please. So seamless SR is an extension to existing seamless MPLS architecture. So to be able to satisfy these end-to-end TE constraints, a BGP LU has some shortcomings. For example, in this network, if we see for the PE5 loopback, BGP LU on PE1, BGP LU gives just a single path to the remote loopback, and that single path is mostly chosen based on BGP best path selection. So here we need a way to advertise multiple paths to the same loopback. So this seamless SR architecture proposes an extension to BGP protocol. The solution consists of what are called as transport classes. So these transport classes are transport class is a set of tunnels that satisfy a certain constraint or certain intent. Transport ribs are a collection of tunnels that belong to a single transport class. BGP-CT is a protocol extension. It's a new family, and it has a route distinguisher in the NLRI. So the purpose of route distinguisher is to uniquely identify the prefix and route distinguisher pair to a particular loopback. And there is a route target. This is the route target extended community that gets carried in BGP-CT advertisement, and route target corresponds to the transport class that the BGP advertisement belongs to. And then there's a mapping community. So this mapping community is a BGP extended community in BGP protocol, and then it is used to define the service mapping requirements for that particular BGP-CT advertisement. So if you see here, the BGP-CT, with BGP-CT, you can advertise multiple BGP advertisements for the same PE5 loopback, and you get end-to-end red, blue, and yellow yellow paths. Next slide, please. The forwarding state looks the forwarding on the packet looks very similar to BGP-LU. There is no really any difference. So the way the BGP-LU label gets swapped on the border nodes, the same mechanism will be applicable for BGP-CT as well. So in this example, we have this loopback PE5. The top part shows the BGP-CT advertisements, and the bottom the bottom boxes show the label, the packet forwarding with respective label operations. So if you can see the leftmost PE5 advertises a prefix PE5 with a route distinguisher, and then the route target, which is red color for the end-to-end red path, and then it associates a label and then sets next stops to self and then sends it to ASBR7, and ASBR7 changes the next stop to self and then advertises another label for the same prefix, and that continues till the advertisement reaches PE1. If you see the VPN advertisement, has a VPN prefix V1, and then there is a route distinguisher and route target. So this is VPN route distinguisher and route target, and this is not in any way related to the BGP-CT's RD and RT. So in VPN advertisement, the RT specifies the VPN membership. In BGP-CT advertisement, the RT specifies the transport class membership. And to simplify the service mapping and then to allow auto steering, this extended color community is used. So if you see, the VPN prefix carries the extended color community red, and the route target in BGP-CT advertisement carries the same extended color community, which directly maps to the extended color community red. So on the ingress, the resolution of VPN on this red path will be automatically done based on the extended color community in the VPN advertisement. Next slide, please. So we have an example use case and how this can be achieved with seamless SR. So this is a use case where there are multiple ASs, AS1, 2, and 3, and it roughly represents each continent. And so there is a data sovereignty requirement which requires to avoid node A and C in AS3, as node A and C belong to a particular country. So because this is a network which is geographically separated, the avoid node A and C constraint is not applicable in AS1 and AS2. Next slide, please. So if we see a red LSP is created on ASBR4 in the AS3 domain. So any mechanism can be used to create this this red path in the AS3. It could be FlexAlgo, it could be RSVP, or it could be SRTE. So since ASBR5 does not have a red path which avoids A and C because it's connected to A and C, ASBR5 does not create a state for red LSP. So once the red LSP is created in AS3, the red transport class is created on all the border nodes. And then there is a resolution policy which is advertised by the mapping community, which says in AS3 the resolution is to be strict resolution to use only red paths, whereas the mapping community on AS2 and AS1 will say if red path exists, resolve on that, and if that doesn't exist, use best effort path. So if we see in AS1 and AS2, the red tunnels, intra-domain tunnels, red tunnels are not created in AS1 and AS2 because it's not, the constraint is not applicable. So the traffic is just going to follow best effort path. Whereas on the border nodes, there is a state created for the red transport class. And separate label advertised for the red transport class. So on PE1, the service, when the service prefix which needs to honor this data sovereignty requirement will use the red color community and then use red BGP CT labels to forward the traffic. And if, as you see in this diagram, you can see the traffic going from PE1 to ASBR1 and to ASBR2, and then ASBR3, 4, and then use the red LSP in AS3 and then reach PE2. Next slide, please. So this is some details on how the advertisement is done. BGP CT advertisement is done and state created on each of these, and then there is the bottom section shows how the packet forwarding happens. So if you really see the packet forwarding uses bottommost is a VPN label. The next label is a red transport class label, and if you see ASBR3, ASBR2, ASBR1 advertise a label for red transport class, and that label is used in the packet, so that when the traffic hits ASBR4, it will use the red transport class and go over red LSP in the AS3 domain. Next slide, please. So we request review and comments on this document. Any questions?
G?
I have two questions about this presentation. The first is, as you've shown in this slides and also in the document, I see segment routing is just used as one type of the tunnel, and RSVPT and LTP can also be used under this architecture, right?
Yes, correct.
So could you please clarify why it's called a seamless segment routing? And
so it is also going to interwork with other SR technologies such as SRv6, SRM6, and so on. So that is the reason it is named as seamless SR.
But it can be broader than segment routing, can interoperate with other technology also, right?
Yes, that is very clarified in the document. So if the comment is only about the name, yeah, we can think about that. I think we don't have to use working group time right here. We can discuss that over mailing list.
Okay, then the second question is, I see most of the mechanisms and the extensions are defined or specified in the another draft in the IDR working group. Then the question is, does this document belong to the standard track, or is just an informational document?
It belongs to standard track because this document is going to talk about the architecture, and it is going to describe what in normative in terms of requirements and what the architecture should handle.
So there's some changes or update to the segment routing architecture in this one?
No, there are no updates to the segment routing architecture. So it is basically going to talk about how to connect multiple domains with a BGP-based mechanism. So that's going to be the use case, and it is not going to update or make changes to the SR architecture, and it just uses the terms and definitions and it will comply to the SR architecture fully, 100%.
Okay, thank you.
Thank you.
Thank you, Charlotte. Next, I believe, is Yimin. By the way, anyone can go to the mic queue anytime, just like during a physical meeting. And also, it's best practice to say your name on affiliation when you speak. Even though we see your name on the chat, I'm not sure it will be how it will be seen on YouTube. So it's better to state your name. Yimin, are you on the room? Or any other co-author? Otherwise, we can skip it. Or Yimin Chen or Jeffrey? I see you're sharing everything except your mic. So, Essie, do you want to say something, or you have your mic, Essie? Essie? Essie Linden?
No, I don't wish to say anything.
Okay, sorry. So maybe we can skip to Rakesh and Yimin. If you're here, we'll come back. Rakesh Gandhi. Yes, thank you. So you have the mic. No, you don't have the mic. Yes, ask. You're being disconnected there, Rakesh. I don't know why. Maybe try to ask again. Rakesh? Rakesh, I see you in the queue or in the mic, but you get disconnected every time. You're asking for the video. Usually it's not helping, but Rakesh, from what I see, you have the mic, but you're being disconnected every 20 seconds. Otherwise, do we have any co-author who wants to back up? In the meantime, if Yemin, if you're in the room, virtual room. Rakesh, yes.
You hear me?
Yes, I do. We do.
Okay.
Thank you very much.
I'm very sorry. Something is wrong with the Firefox. Sorry, guys. I'm Rakesh Gandhi. I'm presenting this draft on enhanced performance monitoring for segment routing on behalf of the co-authors listed. Next slide, please. So the agenda is to go over the requirements and scope, the summary of the proposal, and the next steps. Next slide, please. So the requirement and scope of this draft is performance monitoring, delay monitoring, as well as liveness monitoring for end-to-end SR paths. It's applicable to SR-MPLS and SRv6 data planes. Basically, to run a single protocol in SR networks, that's where the motivation is, to simplify the implementations and reduce operational cost. Also, for the operators, simplify the deployment and operational complexity. So to avoid the endpoint dependency, stateless on the endpoint to allow higher scale and faster detection interval. The scope is using the TWAMP Lite 5357 and the simple TWAMP RFC80 7862 probe messages. Next slide, please. So draft was presented in MPLS working group at the last IETF virtual meeting. Next slide, please. So to run the PM probes in loopback mode, the TWAMP message is used using the segment list of the SR policy candidate path. The packets are not pointed on the reflected node, and they are simply forwarded just like data traffic. Next slide, please. So in enhanced performance monitoring mode, the probe packets on the reflected node, there is network programming function enable, and it allows to optimize the operations upon and add timestamp and re-inject the probes and avoid that function and process in the fast path. So this will, make the faster liveness failure and performance monitoring possible. The reflector node, because of the network programming function, will add receive timestamp in the packet and forward the packet. And it's only done by the intended reflected node by matching the source address or destination address in the packet. Next slide, please. So failure is notified if some M number user configure probe messages have delay values exceed the user configure thresholds and counts. Same way, liveness failure is notified. It's a loss of heartbeats when consecutive N number of probe messages are not received back at the sender. Both these counts are user configured. Next slide, please. So if using TWAMP messages or simple TWAMP messages, there is a transmit timestamp that's added by the sender, and there is a receive timestamp that's added by the reflected node using the network programming function. It's added at the byte. It's locally programmed, and in this case, the offset would be 16 in the payload of the TWAMP or stamp probe message. And next slide, please. So in case of SR-MPLS, there is a special purpose timestamp label defined in INA. This is requested, and the source and the destination addresses are swapped. So it's sent on the SR-MPLS path. The reflector processes the timestamp label. It adds the receive timestamp in the fast path, and the packets is looped back to the sender. So this is the timestamp and forward function on the reflected node for SR-MPLS. Next slide, please. For SRv6, idea is very similar. There is an endpoint SID function defined to do the same network programming. And when, as part of the network programming, the reflector node will add timestamp and forward the packet back to the sender node. Next slide, please. The mechanisms also allow the ECMP measurements for ECMP paths for SR. Is using the hashing function in forwarding. So for IPv4, like we could do sweeping of the destination address 127.8, or for IPv6, the sweeping of flow label in the v6 header. Next slide, please. So the example provisioning model, so these are user provisioned things, so there is no signaling involved. So defining the which mode, loopback mode, or the enhanced network programming mode, which protocol, so is TWAMP light or stamp simple TWAMP, how many miscounts, in case of MPLS, the network programming timestamp label, it would also be INI allocated, and a timestamp format and the UDP ports are user provision. Next slide, please. So we welcome your comments and suggestions, and we are also requesting working group adoption for this draft. Thanks. Any questions, comments?
Usually we would see how many person read the draft, but it may be difficult here. So we'll see on the list.
Okay, thanks.
Person in the queue. Greg, I've just given you permission. Go ahead.
Yes. Well, first, the general question. So you say it's a liveness monitoring. Can you clarify liveness of what?
So this follows, in case of SR policy, the probe messages follow the segment list of the SR policy, and it's received by the endpoint of the SR policy. So it basically follows the same path as the data traffic that's sent on the SR policy. So if you are sending on the SR policy path, you are monitoring the path of the SR policy segment list or candidate path.
Okay, so it's a replacement of BFD then?
So this is enhanced performance monitoring. So it allows you to measure like using the TWAMP or stamp messages, measure the end-to-end delay, as well as detect any liveness failure at the same time.
That's what I'm wondering. So, because neither TWAMP nor STAMP are fault management protocols, so they're not defined as a protocols to monitor the path, whether path continuity or connection.
Yeah, so by sending basically in any liveness protocol, you are sending probe messages along the path that you are monitoring. And if there is a loss of connectivity, the probe messages are not received. And this is how we know there is a liveness failure. And packet format can be anything. In this draft, we are proposing TWAMP or simple TWAMP to leverage the existing implementation and deployments. But packet format can be anything. The idea is the same.
Yeah, but the protocols that monitor, because again, I think that liveness is very confusing, because probably I would recommend to look at how BFD scope is defined, or CFM. But one of the elements of these protocols that monitor proactively on each end is that there is a known rate of probe messagings being generated. And neither TWAMP Lite nor STAMP have this information in the packet. So there is no, that's why I wonder how the far end will determine what's the expected rate of these probe messages, and how then calculate. Because, for example, if we look at BFD, there is a whole machinery of negotiating the interval between the two endpoints. And then there is a detect multiplier, which is essential to calculate their detect time. In CFM, it's a little bit different, but still, they hard-coded that 3 messages in a row missed to constitute their defect. So I don't see in the document that being introduced. So where this information comes from?
Yeah, so I think the whole theme of the solution is that the reflector is unaware of the there is no punt, there is no reinject, there is no RAID, there is no LPTS. It's really fast path forwarded, just like data traffic. So there is the whole concept of this rate limiting, exchanging the rate information. All of that is not needed in this enhanced performance monitoring. That's why we call it enhanced, because it's a significantly a step forward compared to existing technology.
Yeah, well, yeah, but I don't think that you answered my question. So let me rephrase. So you say that you plan to use this mechanism to monitor path continuity or connectivity if you're strict segment routing. So how the reflector knows the expected rate of arrival of test packets?
So there are 2 ways to answer that. One is that the whole model for this enhanced performance monitoring is there is no signaling involved. So it's all based on locally provisioned parameters. And the second thing is that this particular issue of rate doesn't exist for this solution, because the packets are fast forwarded. It can be sent at very high rate without needing to punt. There is no state, there is no knowledge of I'm running this protocol on the reflector side.
How there is no knowledge if you claim that you monitor the path continuity. So you need to know that their session is up. So if you look at state machine, there is some state what's up when it's down and when it's initializing. So that is really confusing. But let's go back to the beginning of your presentation, if we can scroll back.
Okay, just one short point, Greg, because we have two more people on the mic.
Okay, yeah, okay. In effect, I think that there was some confusing statement saying that TWAMP and STAMP operate in some loopback mode. Can you explain what you mean by this loopback mode?
So it uses the messages defined in RFC 5357 or the STAMP, but it's not used. There is no punting done and no injection of the probe done on the reflector. It's sent and come back to you. It's forwarded by the reflector node just like any other data packet. So this is why the reflector is unaware that there is a protocol being run or there's rate limit, there is no state there. So you can run at very, very high speed.
That's, again, I don't understand this terminology, loopback mode, because normally both TWAMP and STAMP are expecting their reflector to do some processing. So whether it's even stateful reflector or stateless as defined in STAMP RFC 8762, there is no such thing as reflector blindly sending packet back, because that would not work.
So the reflector is not aware of running the TWAMP or STAMP protocol. It's only IP forwarding the packet, just like any customer data packet. So this is how it is different.
It's not part of the protocol. It's something that you're inventing and then presenting as a property of these protocols. I think this is misleading.
Yeah, it's mentioned. We mentioned that in message format it can be TWAMP, a STAMP, or any message format that we can define. It's not dependent on a TWAMP or STAMP. But the reason we have this in example is that there is a high deployment for this protocol machinery. So there is affinity to use this message.
Well, okay, if you saying that you want to define any packet format, then you don't need to refer to these protocols, because they're protocols for the reason, because they are based on some specification which defines the protocol. If you're inventing some new protocol, then you're inventing new protocol.
Yeah, I mean, there is nothing in the draft. This RFC says that you cannot use this message format for anything else. If you decide to use that message format to make processing easier, it is fine.
Greg and Rakesh, do you hear me?
Yes.
Yes.
Okay, sorry, I was muted. Could you continue the discussion on the list, please? Because we have two more people on the mic. And
yes, okay, sure. Thank you.
We'll miss your last slot. Zaou? No, okay. Andrew? No, Zaou, yes, you have the mic.
Hello?
Zong?
Yes, can you hear me?
Yeah. So, looking
excuse me, Andrew.
Draft,
Andrew, excuse me.
It's Andrew here from Liquid, by the way. Looking at this draft from my perspective, I can see a lot of use cases for it for monitoring performance. I wouldn't use it necessarily for liveness detection. I think there are other protocols probably better suited to doing that, SBFD, BFD, etc. But I do see advantages in using this for actual timing across a path. And then my other comment on this, you've said that in the draft, it doesn't really kind of limit you to specific, TWAMP or stamp. But I point to the fact that Section 5.2 actually does specify RFC 5357 and 8762, etc. So if you do intend to use potentially other protocols, etc., you may want to clarify the wording of this document, because this document does seem to be very tied to TWAMP and STAMP at the moment.
Yeah, that's a good feedback, Andrew. We will definitely address the comment. And the first comment that you had about liveness is kind of there is no extra protocol machinery required for liveness. If you will, you kind of getting it for free, right? There is no state, there is no extra functionality, except you know that your probe messages and continuity checks are failing. So you are using simplifying the protocols in the network by detecting the loss of continuity. So you're just getting it for almost free by doing the enhanced performance monitoring.
Zhao, did you want to say something?
Can you hear me?
Yes.
Okay. So I was trying to say that I'm sorry we missed the chain replication presentation. If possible, we can present at the very end.
I'm sorry, we won't have extra time.
Okay, that's fine. Thank you.
Thank you. And we'll cut the line now because we have 2 more slots. Can you make Thomas and Ivanshu, can you make your comments on the list, please? Thank you. Rakesh, you have 10 minutes for your next 2 presentations.
Yeah. Hi everyone, Rakesh Gandhi from Cisco. I'm presenting this draft on performance measurement using a simple TWAMP in segment routing networks on behalf of the authors listed. Next slide, please. So we'll look at the requirement and scope, the history of the draft, the updates we made since it was presented in Singapore, the summary of the changes and the next steps. There is, in the backup of this presentation, we do have slides that was presented in Singapore for the links, SRMPLS policy, SRv6 policy, the provisioning model, and ECMP. So we will not go over what was presented, but we will just present the updates. Next slide, please. So just to refresh the requirements and scope of the draft is the delay and loss performance measurement for links and SR parts for P2P and P2MP. Links can be a physical, virtual, lag or lag members. Idea is to also measure the ECMP for SR parts and also support the standalone direct mode loss measurement. And this is the using simple TWAMP. There is a new RFC 8762 that was published earlier, and there is also work going on in IPPM to add TLVs for this. So we are using the great work that Greg has done along with his co-authors in the IPPM working group. So this is being used in segment routing network. Next slide, please. So about a year and a half ago, a draft we had on TWAMP. Yeah.
Sorry. Can you please focus on the main points, because you don't have much time for your 2 slots.
Okay. Yeah. So
thank you.
Draft has been around, but in March we split the draft to move the stamp to a different this new draft. So and TWAMP is one draft and the stamp is another draft because of the 2 different RFCs and the mechanics are a bit different. So since Singapore, we have added a flag for in-band response request. There is a destination address TLV defined. Remember that STAMP allows the TLVs. There is a return address TLV also defined for STAMP, and there is an update to the INR registry action based on the review comments and some editorial changes. There is a STAMP TLV draft was updated, so we have one update pending for this draft. Next slide, please. So there is a flag defined to receive the response in band, and this is useful for a bidirectional SR path to receive the response message back on the same path. Next slide, please. So as mentioned, if you're doing one-way measurement mode, reply is sent out of band, and if you're doing two-way measurement mode, where you have 4 timestamps, you get the reply back in band, and it's based on the control code flag that we have defined. Next slide, please. So we have defined a TLV for the destination address. So if there is an we're using 127.8 destination address. If you want to make sure that packet is indeed processed by the expected or intended destination reflector node, there is a destination address added in the message. Next slide, please. So in the return address TLV, we now also added a return address. So if you want to get reply back on a different node other than the sender, for example, there is a sub TLV for it. And we already had the sub TLVs for the SRMPLS or SRv6 labels to receive the reply on a specific SR path. So draft has a standalone LM message defined. It's very similar to the standalone DM message that's there in the same STAMP. It's a different UDP port used for the LM, and that it does not modify any procedure in the STAMP. So it's a completely orthogonal message. Next slide, please. So we welcome your comments and suggestions. There is an implementation that exists for this. We are requesting Spring Working Group adoption. As the base work is happening in STAMP, we have been keeping the IPPM. We have been keeping IPPM Working Group in the loop about the milestones, and we are also presenting this draft in IPPM on Friday. Thanks. Any comments, questions?
Yes, Greg has a comment. Greg, you have the mic.
Do I? Because I don't see it on my... Okay, thank you.
Yes, you do.
I have two questions. First question, so you propose to modify STAMP base packet format by introducing this code of how to return?
Yeah, the control code for the in-band response, yes.
Well, in that case, I would strongly encourage their working group chairs to discuss it with IPPM working group chairs, because in this aspect, you're modifying the base RFC 8762. Another question I have is, so you said that you need to have standalone LM message?
Yes.
STAMP protocol does loss measurement and delay measurement in its base specification. So I just wonder, can you explain why you cannot use RFC 8762 to do loss measurement? Because it includes their sequence numbers. And then if you have a stateful reflector, you can do not only loss measurement in one way, in round trip, but you can do it one way loss